So we are to find from the first principle the derivative of f of x, that is having the function as x plus 2 exponent 2, both in a bracket. Now, what are we going to do? Let's start without wasting time as the solution. Let's take this as f of x equals to x plus 2 all squared. Since it's having a square, it will be easier for us if we expand this as well. Then the easiest way to do that is square the first term, which will be x squared, twice their product, meaning the product of the two numbers times 2. 2 times 2, 4 times x. That will be 4x. Square the last number. 2 squared will be what? 4. So this is what we are going to have. Now, we can recall from first principle that if I am looking for the derivative of this is equals to the limit as x is approaching 0 of the function x of x minus plus age minus this divided by age. Sorry, as age approaches what? 0. Now, what are we going to do? That's a small change we are having there. Now, we can see that this is what we are having here. But in the case of this, we don't have it. So let's deal with that first. So if I take the function x plus h, that is the function of f with x plus h, you can see there whatever you are seeing in here in the bracket is what is represented by the x. So if the x is being increased by a small change, the value of x in the original will also be increased. Meaning the case here will be x plus h squared plus 4x plus h plus 4. I guess you get it? In the case of this, x is being increased by 1. So if x is 4 and you are increasing by 1, it will be 4 plus 1. So we add a change. Here, the x is squared. So if I find the change of the x and h, I will square that. With the same explanation here, we can expand this, square the first, that will be x squared. Their product will be xh, twice of that will be 2xh, right? You square the last term to be h squared. We can expand this to have 4x plus 4h, then plus 4. Do we have any common factor? X squared, xh. No, we don't have any common factor. So we are going to lift the whole of this and place in place of this, then this divided by this. Alright, so we can say that from the first principle, we have the derivative of x, f of x is going to be the limit as h is approaching 0 of f of x plus h minus f of x divided by h. So we can do our substitution from there. So in this case, I am going to replace the f of x plus h with all these wrong values. Let's try. The board is not big enough, but we have x squared plus 2xh, h squared, 4x, 4h, plus 4. The whole of this represents this, right? Don't forget the limit is still there. So let's take that minus the function this, which already we know from here as x squared plus 4x plus 4. So all this is still divided by h with the limit attached. I think we don't have the space in there. Now let's do some cancellation as possible so that we can be able to have enough space to write. I see this negative is having effect with all the terms in the bracket. So meaning this is going to be negative x is positive x squared. So it becomes negative x squared, negative 4x, negative 4. So this and this will become a common term, x minus x in terms of power. So you're having this and this are like terms, so it becomes 0. Positive x, negative 4x, 4x, negative positive, it will also cancel. Then the constant 4 and 4 will cancel. So therefore, our differentiation with the limit as age is approaching 0 will be left with only 2x, let me bring it closer, 2x age plus age squared for age, all divided by what? Age. That's the only thing left. Let's cross check and see if that is true. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the terms we have. But if that is the 6, we are taking away 6 again. So if we take away, we are taking away 3 from the 6. So we left with 1, 2, 3. If we are taking away 1, 2, 3. So the 3 terms is okay. In the case of this, there are 2 ways we can do this. We can divide each of the term by age, or factorize the age out, which I can see as a common factor. So I can say this equals to the limit as age is approaching 0. If you pick the age out, you'll be left with 2x. Here you'll be left with only age plus 4 divided by age. And I'm sure you can see that the age will clear off from this case. This numerator will cancel that denominator. So you'll be left with the f prime of x, the limit as age is approaching 0 of 2x plus age plus 4. So if you introduce the age with the 0, we are going to see it only one place. So let's go. So finally, our f prime will now become, if you introduce, you have 2x plus 0 plus 4. And that will give us 2x plus 4. So if you are to differentiate this directly, 2 come forward to multiply to give you this 2x, as you are seeing. If you differentiate this, it will become 4. This becomes 0. So exactly this is what you are going to get on a direct differentiation. But here we are using the first principle. I believe you are able to follow, even though the board is not big enough to take the long sentence aspect of it. You are able to follow through. Thanks for watching. Like, share, and comment. Subscribe if you are new to the channel. Bye-bye.